what I'd like to do now is just give you an introduction to materials and how materials work in the 3D world. Now, before we start jumping into 3D Studio Max and looking at the nuts and bolts of how the material editor works, I want to just take a little bit of time just to talk and to lecture about what materials are and how they work. So there are 4 ways that we can split materials when we're working with them, and pretty much we can say color, roughness, reflectivity, or transparency. Okay, so the color can be defined in 3D. The color of an object is called the diffuse channel. Okay, now that can be defined as either being a solid block of color, or we would use a 2D image called a texture, and that would be a photograph of a brick surface, or it would be a photograph of a wood plane or something like that. And that's what we would use to define the color channel. We can also define the roughness of a surface, and that can be done in one of 3 ways, either by a bump map, a normal map, or a displacement map. Now, a bump map is a 2D fake, and we use a grayscale image for that. A normal map is a little bit more complicated, and it's a halfway between a bump map and a displacement. It's normally used in games and real-time applications, so if you're working in that industry, we'll talk a little bit about that maybe later. But we've also got something called displacement. What displacement does is, whereas bump map just gives you a lighting fake, displacement actually puts extra geometry into your scene at render time. Okay, so normally if I want a surface to look rough, if it's in the middle to the distance, far background of my scene, I'll probably just use a bump map because it's quite quick to render. But if I've got something that's up close and I want it to look detailed, I'll probably use a combination of a displacement map to give me my low frequency displacement and a bump map to show me my high frequency displacement. Now, an example of that would be something like a brick texture, for example, where I would use displacement to displace each one of the bricks from the surface of the wall, and then I would use a bump map to show me all the pitting on each one of the bricks. Okay, so simple explanation there. Reflectivity. Reflectivity splits out into 2 things. It splits out into specular highlight, which is that little light reflection that you see off a car or off a shiny object, and also environmental ray trace reflection. Now that would be from something like a mirror or a very, very shiny surface where you can see the rest of the room. Typically, objects which have very high reflectivity for their environmental ray tracing will also have a very high specular highlight as well. Transparency is the last thing, also known as opacity, and that kind of comes in 2 flavors. You can either make an entire material semi-transparent or transparent, such as glass, or what we can do is we can be a little bit more cunning and we can use a 2D image that's black and white, and we can actually mask certain areas of our material to be transparent and certain areas not to be. Now, one classic example of where you would use that is in a chain link fence. If you think about it, you think of all the modelling that we've done so far. Imagine what it would be like if you had to go around and make every single link in a chain link fence by hand from geometry. It would take hours, so we don't bother. What we do is we use a 2D image and we put that on a flat plane, and that then gives us the same sort of effect that we're looking for. So let's just briefly have a look at what all of this means in terms of our 3D world. So I'll just minimize that down. And you can see here we've got 4 examples on the screen. You may note with some amusement that we are actually using teapots today. We will always be using teapots when we talk about materials because they give off a good concave and convex surface that shows off specular highlights and material distortions very well. So what we've got up here in the top left hand corner, this is just a simple colour that's been applied to this teapot. It's a simple green colour and we haven't done anything more to it, so that's all been applied in the diffuse colour channel of the material. Down here what we've got is a ray traced material. You can see here we've got the highlights, the specular highlights, And then we've got environmental reflections of the floor and also the other teapots. In the top right hand corner, we've got a bump map. Now, we know that this is not distorting any of the surface, because if I go and look at my display by alpha channel, you can see here that there is no distortion on the surface edge. Okay, turn that off. Looks like a very bumpy material. Actually, it's not. The other thing that we've got here is a material that's got some opacity on it. And what I've done is I've just put a simple black and white checker map on here. And what that's done is that's allowed me to burn right the way through the material so you can see through to the other side. I've also incidentally made this material double-sided so that you can see the base as well, so you can see through it to the other side. So I've kind of cheated a little bit with that. So really, these are our 4 materials, and if I just come back to this, we can actually use these 4 elements to define any single type of surface that we want to. Okay, so let's, for example, pick something like a desk, shall we? A simple office desk, nothing too spectacular about it. The colour of the surface of that desk isn't going to be a solid colour. It's going to be a 2D image, probably a wood texture. Okay, the roughness of that surface, well, it's probably going to be fairly smooth, with maybe a little bit of fake pitting in there as well from the veneer over the top of it. So I'd probably just use a bump map to define that. The next thing is the reflectivity. Well, it's not going to be a very reflective surface. It might have a little bit of a very dull highlight on there, but not very much. And as for the transparency, well, it's going to be completely opaque. Completely solid, not opaque, solid. If you look at something like glass or a glass window that may be in front of you while you're watching this, if you look out of the window, you'll see that the material itself, that is opaque, it's completely see-through. It's probably quite reflective, and there's probably some specular highlighting on it. It's not going to be rough, it'll be completely smooth. And the colour, well, it may well be a slight sort of grey-blue colour, or it may just have a light blue tinge to it. If it's tinted glass, then it'll probably have whatever the dark tint is in there as the block colour, as opposed to a 2D image. So just coming back, this is what they all look like, all those 4 elements, and we can use those in combination to create any type of surface that we want.